In this video, we are going to do an introduction to risk and return. If you want to calculate expected returns of an asset, you would do similar to a weighted average of returns. The way the weights are assigned are by the probability of a state in the economy occurring. For example, if there's a 40% chances the economy is going to do as expected, then there could be a 20% chances of the economy to do better than expected. And then let's say there's another 20% chance of a recession and another 20% chance of a deep recession. So those will add up to 100% or 1, as probabilities do. And what you do is you assign those percentages as the weights for each potential return on those different scenarios. So it really works just like a weighted average, but the weights come from the different probabilities of the different returns. There will be a video with an Excel sheet going over the calculations with an example, a numerical example of this. With variance, you would do a similar thing about the weights. It's like a weighted variance. Notice it also has a symbol here for the probability. The difference of this variance and the variance we have done before was that after going through the process, at the end, you divide by n, or n minus 1 if it's a sample versus population, meaning that you divide by all the items, the total amount of items. However, instead of doing that, notice there's no division here. What you do have is that probability there that works as a weight. So it's a weighted variance. Same thing, there will be another video on an Excel sheet going over the calculations. Portfolios, here we're just going to do a definition. The portfolio is a collection of assets. We typically think of a portfolio as many different stocks, but you can have a business portfolio. You can have, if you, let's say you own several different businesses, or you can have a portfolio that has businesses, stock, real estate. It could be any combination of assets. An asset's risk and return impact, how the stock affects the risk and return of the portfolio. So you have this combination of assets and they all have different returns and levels of risk. Depending how you have your capital allocated across these assets, each one will have an impact according to its risk and return relationship on the portfolio. The risk return trade-off for portfolios measured by the portfolio expected return and standard deviation, just as with individual assets. However, and we'll talk about this more in a moment, each individual asset will have a risk and a return. And when you put them all in a portfolio, it's not as simple as an average of risk return of all the assets or a weighted average. The returns will be like that, but the standard deviation will not. So when you combine them, something changes, and we'll talk about that in a moment. So if we were to calculate a portfolio expected returns, it will be the weighted average of the returns of the assets. So you have 3 assets. One is 40%, another one 30, and another one 30. Then what you have is the one with 40% will have a weight of 40% of the on the entire portfolio, the impact. So it's a weighted average, just like you know it. So for example, while they're both weighted average, as we spoke about this one before, you have an actual asset with returns and different probabilities. So let's say you have like 5 different stocks and you do this for each one of those stocks, and each stock will have the expected return. So then what happens is when you put those stocks and you combine them in a portfolio, now you take the returns of each one of those stocks and you multiply it by the weight they represent in the portfolio. And that's how you get the portfolio expected returns. Now, the expected returns work that way. You can do a weighted average. However, as I mentioned before, the standard deviation does not work that way. If you were to just do a weighted average of the standard deviation or just an average, then there will be no point of combining stocks. There'll be no advantage of doing that. So what you do here is you would calculate standard deviation in a different fashion than that is not the weighted average, and we'll go over that later. The point is that you can then get an average return that is representative of all your stocks, but you have reduced your standard deviation, meaning you can get the same returns for less risk. And that is the whole point of diversification. Here is somewhat of a graphical representation of how that works. What you have here at the bottom is if you have only one stock versus a portfolio with 10 different companies, 10 different stocks, not 10 shares of the same stock, 10 different companies, 20 different stocks, 30 different stocks, 40 different companies, 1,000 different companies. Okay. So remember, it's not 10 shares of the same company and 20 shares of the same company. It's 10 different companies, 20 different companies, and ideally in different industries. So what happens is you have one stock here on the y-axis, we have the standard deviation. In this example, it could be any number really, but this one stock puts you at a 49.2 standard deviation. So you're absorbing all the risk possible from that stock. The point is that as you start combining different industries, different companies, etc., you are getting rid of that standard deviation. Now, notice there's a point where you can't go any lower. That is about as low as you can go on this line here. This line here is the lowest you can diversify. After that, there's only so much you can do, and you must take whatever level of standard deviation of risk is in the market. In this case, they're using 19.2, but that varies as well. So what we're saying is this bottom piece, that line there, that's the market risk, the non-diversifiable risk, the systematic risk. Those are all meaning the same: market risk, systematic risk, non-diversifiable risk. Those are different ways to talk about the same thing. This risk here that everybody is subject to. The top part is what we call unsystematic risk, diversifiable risk. Those are other words for that part where you can diversify away. So far, research and studies have shown that somewhere around 25 different stocks already gets you really close to the line. Some people say you should get 30, but notice that after a certain point here, it really doesn't drop much. So 30, 40 stocks, you get about the same benefit. Of course, the more you do, the more you can continue to try to get some closer to the line, but it doesn't really add too much benefit after so many stocks, different companies. Beta. Beta is another form of risk measurement. Beta, it takes into account the relationship with the market of an asset. So we typically say that if you have a beta of 1, the stock has the average risk in the market. if a beta has, if an asset has a beta higher than 1, then the stock is considered riskier than average. And vice versa. If it's less than 1, it's less risky. So what should happen is, if you have a stock that's a beta 1, you should get about the average return that the market has to offer. If you have a beta higher than 1, then the stock should get a higher return because you're taking more risk, higher return. And the opposite is true. If the beta is less than 1, then that stock is less risky than the market, is one way to express it. So you should get a lower return. Most stocks have betas in the range between 0.5 and 1.5. That is true, but it doesn't mean that you cannot find a lot of stocks out there above 1.5 or below 0.5. The beta of the market is always 1. It's a fixed number because we use the market as the comparison point. So we do is like we say the market, regardless of what's happening in the market, ups, downs, higher standard deviation, lower standard deviation, high risk. What we do is we call it 1, and then we compare everything else around it. The beta of a T-bill is 0, same as the standard deviation is 0 by definition, because we call it the risk-free rate. The payment is guaranteed by the federal government, so there is no risk. Earlier, we said that when you calculate the standard deviation of portfolio, which is a combination of assets, is not as simple as getting the average or weighted average. You had to do a lengthier calculation. With beta, we have the benefit that you can do the weighted average of beta to get the portfolio beta. So if you have a portfolio with several different assets in it, you don't have to do any extended calculations. You can do the weighted average of beta, and that will work. Okay, that will be it for this video. See you on the next one.